Hello my dear students, this is Akash SD and welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Moving Charges and Magnetism. Okay, so let's go through the question. A tightly wound long solenoid carries a current of 1.5 ampere. Now, an electron is executing uniform circular motion inside the solenoid with a time period of 75 nanosecond. Now, the number of turns per minute in the solenoid is how much here? Okay, so you can go through the question and what are the given data is there. So if I talk about here the given data, the current in the solenoid is given how much value? 1.5 ampere. Okay, now the electron is moving which kind of motion? Actually the circular motion. So the time period of that circular motion is given here 75 into 10 to the power minus 9 second. Okay, after that here we have to use the mass of the electron also, and this value in the question actually given we will use 9 into 10 power minus 31 kg. Okay, electronic charge you know very well, and what we have to calculate? We have to calculate number of turns per meter in the solenoid, and this is given by small n. Okay, so this is the data situation. Okay, so now what we have to do? First we have to understand actually what is the solenoid. Okay, so in case of the solenoid, what happens that here, see if I draw like this here, no, like this, no, like this. This is the solenoid, and let's take this length is how much here? L. But here if in the question, if in the situation nothing is mentioned, then we will take which kind of solenoid? Infinite length solenoid. Again I'm writing here which solenoid? Infinite length solenoid here. But you know very well there is nothing like a infinite length, infinite area, nothing like that. So infinite length solenoid means what? The means that the radius of the solenoid is the very small compared to the length. Radius means which length? The cross sectional radius. Now this one I am talking, this is this cross sectional radius. Okay, so what will happen that here, if in case the current will flow in this, now let's take current is flowing in this solenoid here. Now current is flowing. So what will happen that when the current is flowing through the solenoid, let's take the current is flowing, what is given? Like this the current is flowing. So I have to curl my finger along the current, then thumb will indicate the direction of the north pole. So what will happen that this will become north pole and this will become which pole? Anyhow the south pole is there. Okay, this is the south pole, like this I am doing. Okay, so because of that what will happen that here the magnetic field will come inside the solenoid is there. Okay, ideal solenoid means uniform magnetic field will be there. So what is the magnetic field formula? It is given by B equal to mu naught Ni. What is the formula? Mu naught Ni. Mu naught is called the permeability of the free space, N is the number of turns per unit length that we have to calculate here, and what is I? I is the current. Okay, and here which kind of current I have taken? Capital I. Okay, so for that I will use here, for that purpose I am using capital I. Okay, and after that what they are telling that here electron is performing which motion? In this magnetic field circular motion. Okay, so one more concept we have to understand is there. This is the first concept. Second concept what is there? If in case any magnetic field is there like this, no, magnetic field is there, and in this magnetic field let's take for example the charged particle is doing the which motion? Circular motion, like this. Now the charged particle is doing the circular motion is there. Now this magnetic field is there. Even we can use here even the green line also. Now because here I have told magnetic field with the green line. So okay, no problem. I will use here which one? Green line here. That is better. Now so that we can correlate. Now green line means okay, green line. So here what will happen that here, let's take for example this electron is there now. This electron is doing the motion. So for example what happens that let's take this electron is doing performing the motion. So remember that here let's take this electron is there now, and actually I have to do actually V cross B actually, because F equal to V cross B, and in case of electron it will get reverse. What formula I am telling that here? See this one here, for the electron F equal to minus of V cross B. Okay, so that I am thinking actually if in case electron is doing this direction, so what will happen? V cross B in this direction. For positive charge, force upward. That means due to the negative charge, the force will be downward here. Okay, so now I have got the direction here, this one here. Let's take the electron is having velocity in this direction and magnetic field inside. So I am telling that what? V cross B. We have to curl our finger from V to B. V to B means force upward for a positive charge. But this is which one? Negative electron is there. That means the direction of the force will be in the opposite direction of V cross B. That means where? instead of V cross B, it will be B cross B, okay? So like this. So for the negative charge, B is inside, V is this side. So like this here, okay? So students, here what will happen that here on the electron, the force will be in this direction. That is called which force? Centripetal force. So remember that what will happen that here, this centripetal force will work as a, this centripetal force will be provided by which one? Magnetic force. So here what will happen that here, see here, this centripetal force is given by mv square by r, and magnetic force, what is the formula? QV cross B. V and B both are perpendicular, so we can write here QVB. So from here, if I write here, this radius R will come here mv by BQ. What is the radius? Radius is given by R equal to mv by BQ. Okay. After that, students, if here they are talking about the time period. Now, so if I talk about here the time period, so this time period is given by here, see the time period. T equal to, for one revolution, 2 pi r, and the speed is v. That means we can write here, see, 2 pi by v, and r is given by mv by bq here. So what are the things will cancel out here? If I'll check here, this v and this will cancel out here. That means time period is coming what here? Even I can write directly this formula, but I want to make you understand. 2 pi m by bq. What is given? T equal to 2 pi m by bq, and remember that this time period is independent of the speed. Okay. Now after that we'll go further. The electron is moving where? Inside the solenoid. That means what we can write here? 2 pi m, and this magnetic field formula, what this will come here? Mu naught Ni, that we have seen it, into charge Q. And charge means which electron? Which electron? This electron only. Okay. So after that what will happen that here? We have to calculate number of turns per meter. So if I write here the N, what this will become here? 2 pi m, correct? And will go this side. So we can write here mu naught I into E into T. Can you check the formula? 2 pi m by mu naught I into E into T. Okay. Now after that we will further simplify this here. Let's simplify this here. So this is 2 and anyhow pi, and m value how much here? 9 into 10 to the power minus 31. Correct? The mass of the electron. Mu naught value what we can write here? See, 4 pi into 10 to the power minus 7 into current I. Current I how much given here? Let's check out again here. 1.5 ampere. How much given here? 1.5 ampere into E value. E value is given here, students, is the electronic charge. That means we can write here 1.6 into 10 to the power minus 19. And T is what? T is the time period. Again, let's go to the time period. Time period how much given here? 75 nanosecond. That means we can write here, students, see, 75 into 10 to the power minus 9. See here, it is looking somewhat bigger, but okay, we will simplify this here. Now see here. So this pi and this pi is the cancelled, is it? After that, we can solve here, see, this 2 2s are 4, okay. Then after that, what we can tell here, see here, this we can tell here, 3 3s are 9, and here we can write here what, 3 2s are 6, and 3 5s are 15, is it? And after that, okay, we'll collect all these things. Let's collect all these things. So what are the things are there? If we talk about here, this is coming here 3 and here 25. Anything we can do here? Okay, no problem. We'll write here this 3 and into 10 to the power minus 31, and let's collect the power of 10. So what this will come here? Minus 7, and here minus 19 and minus 9. So what we can tell? 19 and 9 how much? 28, and this 7. So 28 and 7 how much here? 35. Okay, so here it will coming here 10 to the power 35. We are just solving. Okay. After that, what are the things are left? 1.5, 1.6 and 25. See here. 1.5 into 1.6 into 25. Now, kindly check out very well. And see here, I think so this 1, 2 is also pending here. No? This 2. This 2 is there. No? This 2. I have written this. Now, after that, what will happen that here? Again, we will simplify this. So, students, we can write here. No? We have to just solve it here. So what we can write here, see, 3 and 1.5. So when I will solve here, you know 3 5s are 15. So it will come here the 0.5 anyhow. So we can write, see, 10 to the power 4 by here 0.5 into 2, how much? 2 into 0.5 anyhow 1. That means it will come here, see, it will come 1.6 into 25 here, correct? And 2 into 0.5, it has become 1. Now this one here, is it? Now after that, further we will simplify this now. We have to just multiply here, see. This is the 10 to the power 4, and here 25 into 1.6. So see, 25 into 6, how much here? 25 into 6, students, 150, is it? So I will take here the 0. 15 is there, so 25 1s are 25, plus 15, 40, 40 and 1 decimal is there, correct? See, I am just simplifying for you, that's it. So what will happen that here I can write here the 1000 by 40. Now see, just simple calculation is there. This 0 0 cancel, and power 4 is there, okay? So this is there. Now 1000 by 4, 1004, how much here, students? So it will become here the 250. How much coming? 250. So students, you can see very well the value of n, what we are getting here, 250, is it? You can see the calculation, is it? Some more calculations are there, JEE question now. So after that, what we can tell here, the number of turns per unit length, this value is coming how much here? We can tell here, this answer is the 250. Okay. So students, I hope so this question is the very clear to you. Keep studying, keep going.